Several of you have expressed some concerns about how to graph things. So I'm creating a series of videos about how to graph line equations. So I'm going to start off with some very straightforward slope-intercept form equations. Slope-intercept form is in this form here. I've got a y equals 3x minus 7. That's in the same form as y equals mx plus b. M equals slope, and B equals the y-intercept. What that means is that equation right there tells me what y is if x is 0. I can prove this by doing this. If I say y equals 3 times 0 minus 7, this is what I'm going to get. So what I'm going to, if I plug in 0 to replace x, I can find out what y is pretty quickly. And the nice thing about this is 3 times 0 is just nothing, so that's just 0 equals 0 minus 7, which just equals negative 7. So I now have a point, which is 0 comma negative 7. You've seen me talk about what is y if x is 0. The reason we call that the y-intercept is that everywhere on the y-axis, x equals 0. So you can figure out where the line goes through the y-axis, its y-intercept, by replacing x with 0 and solving for whatever y has to equal them. Okay, so we now have a point. So I'll plot that point on Desmos. So I've got 0 comma negative 7. And I'll zoom out so you can see it. There it is. There's a point. Now we also know some other information. We know the slope. We know the slope because the slope portion of this equation is right there. It's 3. So m equals 3. That means that we're going to have a rise of 3 and a run of 1. It means we're going to go up 3 over 1 or down 3 and back 1. So what we'll do is we'll plot that. So we go up 3 and over 1, and we would have a point here at 1, negative 4. So plot another point, 1 comma negative 4. I can also go down and back. So down 3 and back 1. That's the reverse of rise and run. Still works because the negatives cancel each other out. So down 3, back 1, I get to negative 1, negative 10. And then if I get my ruler out, I can draw my line right through there. I will demonstrate that that actually worked there. Y equals 3x minus 7. And there's the line. It goes right through those 3 points and an infinite number of other points that satisfy that. Now, if you have this equation, you can also do this without using the slope-intercept form. And this will work for pretty much any equation. So we know we have an output of y, which follows the rule 3 times whatever x is minus 7. So we can actually set up a table here. Now the table is going to auto-calculate this for me. So all I'm doing is I'm setting up x is some number, and then over here is going to be y, which is just 3x minus 7. So if x is 0, y is negative 7. We already know that. We already know that we get negative 4 if I put x as 1. And if I make x negative 1, I get negative 10. But I could use this to get some others. So I'll put in a few points. So if I put in those two various points, I'm actually going to make the line disappear for a minute so we can see this. Zoom out, and we got some other points. And I've just generated a series of points that I can plot on a graph, and then they line up because they follow the rule. If x is some number, y is 3 times that number minus 7. And it gives me a series of xy points that all line up in a nice, neat and tidy line, and then I get my straight edge, and I draw a line through them, and it works. Now, I'd like you to try this with this line, y equals negative 2/3 x plus 5. Please pause the video right now and try this on paper. Graph paper is great. You can rough the graph out on line paper or blank paper if you like. The main point is to make sure you can identify the key points. So pause the video and try this now. Okay, assuming you pause the video, you probably figured out that you had a y-intercept at 0, 5, and you had a slope which equaled negative 2/3. Okay, that allows us to plot some stuff. So I'm going to go ahead and go back here into Desmos, get rid of some of this stuff, and get rid of that. So we know that we have a point at 0, 5, and we also know we have a slope that is negative 2/3. So we're going to go down 2 and over 3. So if I go from 5 on the y-axis, I'm going to go down 2, down to 4, down to 3, and then over 1, 2, 3, 2, 3, 3. So I'm going to have a point at 3, 3. I can also work backwards. So if I go down 2 and over 3, I can also go up 2 and back 3. So from 5, I go up to 7. And then back 3 from 0, I get to negative 3. So I'm going to have a point at negative 3, 7. And now I can just plot my line, y equals negative 2/3 x plus 5, and it works out just fine.